We are going to continue by solving another example. In this case, we need to move the variables to one side and the constant parts to the other. As usual, when we have a linear equation, that's all we need to do. So we get 2x plus x equals 1 plus 5. So we get 3x equals 6 and x equals 6 over 3, which results in 2. And 2 will be a solution for all of this equation. And as we said before, if I substitute 2 instead of x, the left side will equal the right side. Okay. Now last year and in grade 9 we didn't solve linear equations only. We used to solve other types of equations. We used to solve ones that had squares in them, powers 2. So let's say we have x squared plus 2x plus 1. We used to be able to solve this, right? If you remember, try to pause the video and try to solve this on your own. But I'm going to continue anyway. We used to solve very specific types of equations that were of degree 2. We mean by degree 2 an equation that has the highest power to be 2, okay? Or the highest exponent to be the number 2. Okay. So we are going to recall how we used to solve these equations. We used to check if this polynomial can be factorized, if it resembles any remarkable identity, and this one does. It resembles this one. So we factorize it this way, and then we could solve it. It becomes x plus 1 equals 0, x equals minus 1. So minus 1 is a solution for this equation. We also used to solve other stuff like this one, x squared minus 4 equals 0. It also resembles a remarkable identity, and it was this one, a minus b, a plus b. Because we have the difference of two squares, this is a square, this is minus, and this can be written as a number to the power 2, okay, or in a form of a square, of a squared number. So this gave us x minus 2, x plus 2 equals 0. We used to say that the product of two things giving us 0 means that either one of them should give us 0. So x minus 2 equals 0, x equals 2, or we use or because we have two options, okay? X plus 2 equals 0, x equals minus 2. So we have two solutions for this equation. Now let's say we have something of this form, x squared plus x plus 1 equals 0. If we try to use the methods that we tried above, we will not be able to solve this because this does not resemble any remarkable identity. It does not resemble this one, or this one, or this one. Okay? And that's the reason why we are going to talk about second degree equations this year, to be able to solve things of this form, because mathematicians do not like unsolvable things, okay? So